maybe Tim, I hand it over to you.
Yeah,
Thank
sure.
you again for agreeing to this and doing this. And yeah, so the stage is yours.
Yeah, happy to. There's one thing that the host has disabled
Oh
participant
yeah,
screen
yeah,
share.
sorry, have to
Okay.
allow it. Okay, it should be able now.
Okay.
Should be able.
Yep, all good. So if all is well, you're looking at part of my screen.
Yes, it's
So, as already indicated, I have a couple of slides that I'll take you through. Then there'll be a Slido where you can ask questions and folks can upvote those questions and you can work through things as well. Also, feel free to throw things in the chat. I should be able to see that as well as we can talk here. And I have a couple different demos that I can switch to just dynamically. Just I want to make it show that you get the most out of this session of what you're after. So with that, feel free at any moment to steer it any way you want. And then I'll just take you through the first couple of slides and then tell you a bit about the project and what we're after. So with that, this is the title slide, of course, Software Excalibur. But this is a small introduction on who I am. I don't like to focus on myself too much. But if you want to know more about who I am, you can go to my GitHub profile, where timtobeek slash github.com/timtobeek. And there you can watch a silly introduction video of who I am and what I do here at Modern. And you can see that I pretty much work too much. There was a gap somewhere in January where I was out snowboarding for a week, yet still managed to continue contributing to OpenRewrite. But I came into this as a hobby. It's what I very much like to do. And that kind of makes it addictive as well to keep doing so. But perhaps it's good to do a small step back and maybe ask folks like, who here is already familiar with OpenRewrite? It's a framework that allows you to do software modifications in Java, and maybe just throw something in the chat on like what your current experience is with OpenRewrite, which will help guide me on just explain the very basics or go a bit more advanced. So if you have no experience whatsoever, that's also fine. Then I'll tell you a bit more about what we do. And maybe it's also good to know what languages you typically work with. So what is the main language that you are working with? It's also good for input for me to kind of guide this session. So like I said, it's a software modification framework to allow you to upgrade your applications, to improve the code quality of your applications, to improve the security of your applications, and do a lot more beyond that. We currently have some 3,000 recipes, as we call them, small modifications that you can apply, of modification recipes you can apply to your code base to alter things left and right. That can be phasing out feature flags. That can be improving small issues as reported by a tool like Sonar. Or, like I said, upgrading dependencies to move you away from vulnerabilities. All kind of things that you could be doing with OpenRewrite. But I already added like a small tagline underneath the by Modern. It's always painful for me to ask, like, who here has heard of Modern? Because OpenRewrite is getting quite known. I have some friends helping out with like telling folks about it. But even though the logos are just like 90 degrees switched, not a lot of folks have figured out that Modern has some connection to OpenRewrite, which is unfortunate. We have to do the branding twice, but it's I think good to have that distinction as well because OpenRewrite is fully open source. You can use that for free on all your projects. You can use the Maven and Gradle plugins that we have. You can use various other integrations. It's also hooked into other toolings like IntelliJ. It's hooked into CLIs from the team at Quarkus. And there's a few other vendors that have built projects on top of OpenRewrite. But then Modern, of course, we are the main shepherds of the project. So we help steer the direction of where we're going. And we help maintain OpenRewrite. And then we also have a platform on top of that where we aim to allow you to run OpenRewrite recipes at scale. So where OpenRewrite is perfectly able to upgrade your individual project, your one Git repository, your Maven Gradle project, and upgrade that to, let's say, the latest version of Spring Boot, a major framework in Java. With Modern, we allow you to do that same operation, but do it at such a scale that you're able to upgrade hundreds or thousands of applications in parallel. And we have the customers that quite like to be able to do that kind of work, because it's one thing to upgrade it once on a small project, but if you have hundreds or thousands of applications, then you really want to look at that scale, and that's what we offer with Mutter. And then on top of that, we also have some unique capabilities that allow you to do maybe like quick searches from an IDE plugin, or do create visualizations across repositories. Really just allowing you to look beyond a single project with Mutter. Now, a bit about the origins of the project is that we started at Netflix close to 10 years ago, where there was the need to move away from an internal logging framework that they had towards a standard as a Left4j, which already wasn't new back then, but you definitely want to move towards a standard as opposed to maintaining your internal project. But then the problem they were facing is that it is a lot of work. It's integrated all over the place. You have a couple of hundred repositories that you need to migrate. And it's just not something that folks tend to prioritize. No matter how much you want to move away from the one thing with good reason, the folks or the teams are likely going to be pushing back on it. Well, we have features to work on. We don't want to move away from a different library framework just because you need to. So my boss, Jonathan, he got pushback from those teams in the form of saying, well, we don't have time to do this change for you right now, but if you create the pull request for us, we're more than happy to apply it. And that kind of set him off on building something out of spite, which turned into OpenRewrite, where we now have a way to parse your application and then create a detailed model of the code that you have, then allow you to plug in recipes to manipulate that model, and then write it back out again, such that you can overwrite the files that you have and apply changes like moving you from a logging implementation to another. But there's also some tricks involved with this, because there are different solutions that allow you to parse a Java project and create a model, and sometimes even do small changes as well. But we also found that a lot of those, they don't quite respect any formatting that you previously had, or they don't allow you to do larger scale transformations where you need more than one method replaced with another method. You maybe want to do one method replaced with a constructor, or you maybe want to introduce a fully new method definition. All sorts of things that are just not possible with other solutions. We've had to build into this solution over the years. But the neat thing is that once you have that type of framework that allow you to parse code, create a model, and manipulate that model, then you can also look beyond that for other use cases. And the next use case they had is to upgrade you from JUnit 4 to JUnit 5, which by now is already, I think, a decade old or close to. And at the end of the year, there's plans to have a JUnit 6. So it's very helpful now to have recipes where you can take a JUnit 3 or 4 application, build that model, and apply a number of recipes that we have, and then write out the code as it would be for JUnit 5 or 6 going forward. And this is the type of example that I like to use a lot, because it's very clear. It's something that everyone by now who's done some Java development has likely seen before, where you have an annotation, the test annotation. And before, if you wanted to assert that a particular exception was thrown, you would have to add an argument to that annotation to say, well, I'm expecting a no such bean definition exception clause. But in JUnit 5, if you want to do the same type of assertion, now you have to call a different method, the assert throws method, and then add in the same argument, and then give it a lambda of the statements that should trigger that exception. Now, this is something that is a very trivial one if you want to do it by hand, where you just take that argument, add a new method call, and do it that way. But if you have a couple hundred or a couple thousands or tens of thousands of tests to migrate, then you really want to look at automation. And then in the past, a lot of folks have told me that they mostly did that migration by doing some regular expressions for their imports, replacing the org.junit.test import with the JUnit 5 package definition. This is a type of change that is very hard to automate with regular expressions because you have to match an annotation, then anything in between, then take these statements and throw them in a lambda. You're just not going to have a lot of fun doing this type of work with a regular expression. So this is where recipes come in. Recipes allow you to, like I said, create a model, manipulate the model, write it back out. And those are then highly composable, so each do small steps of this migration. And the way this works underneath is, like I said, we take the code that you have on the left, and then a lot of other tools, they operate on the basis of an abstract syntax tree. Those who have had a formal background in IT, they likely know an abstract syntax tree is just a representation of the code that you see on the left. And that can be quite advanced as a model. Typically, it only looks at what you see in a particular source file. But if you want to do migrations, then we found that you have to look beyond just what's in a single source file, and you have to pull in, for instance, type information. Is this test annotation that you have, is it coming from JUnit 4, JUnit 5, test-ng, or something else still? All kind of things that you can only answer if you enrich the abstract syntax tree model with detailed type information, because inheritance might be involved. You really need to pull together a lot of elements before you're able to definitively say, this is a method that I want to match and modify, and then apply the changes that you want and write it back out again. And that last step is also crucial, that writing back out again. We have found that folks are very sensitive to the exact way in which you introduce new changes. I don't think anyone here has not spent an hour or more, has not spent at least an hour or more discussing tabs versus spaces with their colleagues. And we have found that if you introduce new code changes and you mess up the indentation, then your pull request is going to be automatically rejected. So what we have to do, and is typically not part of that abstract syntax tree model, is also include any indentation that you're using. We also should not throw away any of the comments that you had before, or any of the Java docs, all the things that you carefully added to your project over time. They need to be replicated whenever we introduce new code changes. And that is why we have the concept of a lossless semantic tree in OpenRewrite, where we pull in all that information as we need to be able to make changes that are likely going to pass the sniff test when folks look at the suggested changes from a pull request. So then we've seen the model, we've seen the type of changes that you're after. Now let's have a brief look at the ways you can define the changes that you want to apply. And we have, in general, three major ways in which you can define the recipes that you want to create. All the way on the left, we have the declarative recipes, which are a very building block way of composing the changes that you're after. We have some building blocks, for instance, for all the things that you typically read in a migration guide. If you have a change log and they tell you, well, we renamed this class because we thought it would now better fit if we renamed it this way, or we moved the package, or we changed the version of a dependency, or we changed the artifact ID of a dependency. We changed the order of these method arguments around, which is something that you see in JUnit 4 to 5. Very fun, your compiler won't warn you, but you should swap those two around. All of those types of operations, we have building blocks for on the left-hand side, where you can say, well, I want you to match this exact method, and then I want you to replace the method name with this new replacement. Or I want you to, like I said, swap these arguments or do any kind of these manipulations. And that typically we find allows you to do 70, 80% of the migrations that you're after in a larger framework migration. A lot of it is silly stuff that we had somehow accepted over the years as just something that is part of your day-to-day work. And it can be as much as 30, 40% of the work that you do, just trying to keep up to date with libraries and framework versions that come up. But it's really something that you should be automating. So we have a lot of recipes in the left-hand side of this space just to do those silly types of things for major libraries and frameworks that we support. Now, if you need slightly more, or you have something that is quite awkward to express with these building blocks, it's maybe three different things that you want to pull together, or you want to match a typical method and then swap things and rename them and swap in a different type. Then we can also do that with a style that is very convenient, called the refactor style of recipe. I have a more detailed example, just a few slides down. But what it allows you to do is to define two methods, each with a annotation on it, and a body in those methods, which for the first one we're going to match, and for this we're going to replace it for what we see in the second. It's very straightforward, very easy. It's also compiler safe, but it does require that you have a single version on your class path that can be compiled with both the old format that you want and the new format that you want. So if there's a breaking change in your API and there is no intermediate version, then it's not a great fit because you can't compile a recipe that needs two different versions of your library on the class path. So if you need something more, then we have imperative recipes. Those will allow you to take that detailed model that we have of your code, the lossless semantic tree, and then apply the visitor pattern as you traverse over that model and do any kind of wild replacements that you might be after. So that could be swapping out just one method invocation for a different method invocation, but you can also swap out different types of elements. Just one method invocation for a constructor invocation, or replace a literal with a constant, all kinds of more interesting replacements, or even introduce complete new classes. If you, we have a couple of recipes where you need to now add a configuration class in a Spring application, for instance. And then we have recipes that just generate something that wasn't there before. So it's not something that you can easily match, but you can write a recipe that finds out that it doesn't exist yet and it should be created. And we have the API to allow you to do that type of work. Now, within that space, we also have some utilities that allow you to make that work easier. And I'll show you some of that as we get to the rewrite recipe starter, which is more of a demo part of this presentation, to show you that while it is very powerful, it doesn't necessarily mean it's a lot more complex either. So then just to give some small examples of the declarative style of recipes, this is what the recipe for the JUnit 45 migration looks like. Right at the top, you have a name that you give the recipe, and then a list of smaller steps that you want applied under this grouping of the JUnit 45 migration. And the first one is the very silly one, the one that is reasonably doable with a regular expression. Replace that import with the new qualified JUnit 5 replacement, unless you look at those expected exceptions again. So it's not a direct one-to-one match, but it does allow you to do some of the work of the JUnit 45 migration in that way. Now, beyond that, there might be some steps that need a dedicated recipe. So updating the before and after annotations of switching from the assert to assertions import, all of those types of changes, they have dedicated recipes to do some of this work in a imperative style recipe. So where we can, we try to use those building blocks, but where we can't, we can compose a recipe that uses the imperative recipes to do some of that work still. And then we tie them all together into that one larger composite at the top, where you see the JUnit 45 migration. We run all of them. Each recipe will apply its changes and hand off its modified model onto the next recipe. And that line continues until there are no further changes and your project is fully migrated. Now, like I said, we have that second way of defining recipes. That is the before and after templates, annotated methods that you see here for refactor style recipes. And these are great for small kind of things where you can define the change that you're after as something to match in the before method right here. And then the replacement can also be defined in the after method. So this will only work for statements and expressions, because it has to be something that fits into the methods that you're defining here. But it also means that this is all that you need to define the exact change that you're after. We found that this is a great one if you want to standardize heavily on the way things are implemented. So if you have a couple of different ways to maybe check that a string is empty, you can define all of them with such a before template method. And then the after template will mean that whenever this recipe runs, it will replace everything it sees in the top before template annotated methods, replace it with the template here. And note that while we're using a string with a variable named s here, it really is a replacement for anything of the type string. So it doesn't have to be a variable. It can also be a method invocation on which you call .length. It can be just anything that is a string. I've had folks think that they exactly have to match their variable name here and it will only work for variables. Very much not the case. You can anything of the type string will be matched. And there's some more intricacies if you want to use something twice, all different ways in which you can define it. But like I said, it's a great way to help standardize your code because like tabs versus spaces, there's a lot more discussions that can be had on the best way to check that a collection is empty or a string is empty, or the best way to do time operations with the new Java APIs. And having recipes that are as easy to define as this one and then as easy to enforce going forward goes a great way towards standardizing such that you can move away from those discussions and just have them once and then automate them going forward. Now, this is not something that we came up with. This is something that came out of the error-prone project at Google. And we just like the API so much that we didn't think to copy it and do something similar. No, we just really fully took their annotations and their API to define this, to do this type of work. And that had some very nice benefits for us as well. Because as discussed earlier in this call, a friend of mine, Rick Ossendrijver at Picnic, they have some 900 or so of these recipes that, of the style that you see on the left-hand side, where you have something that they want to match, something that they want to use instead. And then what we're now able to do is take those 900 recipes, generate OpenRewrite recipes for them, and enforce those going forward. So we really could greatly expand our recipe catalog by building in this support and then leveraging the error-prone support project that they open sourced at Beek. It's great fun, and it also means that I now get to present with Rick at conferences, which is a lot of fun to show the benefits of each of our tools, and then make folks aware that each of those exist and they're highly complementary, not competing. So then, looking beyond those individual recipes that you can define, it really comes to composite recipes. This is where the magic starts to happen, where if you are looking to upgrade your Spring Boot application from something on like 1.5 on Java 5, 6, 7, and you want to go to Java 21 or beyond and on Spring Boot 3.4, then we have recipes that pull in all these steps that we know about and have automated already to be able to achieve that complete migration for you. And right now, if you run that recipe, you get some 2,923 recipes evaluated on your project, and then potentially making changes to your project. Now, in practice, you'll find that not all of these will match because you don't have both SQL and Mongo and Elasticsearch and some other things in your application, but they are all evaluated, and if they match, they will make the necessary changes. So it really helps you to have 2,923 things that you don't have to read in the changelog and keep in mind as you go through your project, because they will be applied automatically for you. And then, of course, it's possible that we don't yet have recipes for some bespoke RabbitMQ library that you're using in your application. But if you know that the changes that you want to do are something that you can automate easily with a recipe, then that is something that you can write your custom recipe for. And I'll show a bit of more examples and a starter project to show you exactly how to do that. Because while we have support for Spring, we also have support for a lot of other technologies still. So if your language or framework is not on here, please chime in into the chat. We're always curious to know what folks are using and how best to expand the technologies that we currently cover. But there is a lot that you already see covered on the left-hand side. Because we start first building a parser for various languages. We originally started with Java, and that's also become the base model for a lot of other languages that we're now expanding into. So if you have a project that runs Groovy or Kotlin or C Sharp, JavaScript, TypeScript, or even Python, all of those map back to the same Java model that we have, such that we can run some base recipes on all of those very easily. And you might think that they look very different. Well, structurally, even a Python application isn't that different from a Java application. It's just there's indentation instead of like parentheses. But then having that common base model also means that we can run some of those 3,000 recipes that we have on Python application as well. And of course, it doesn't make sense for a Spring migration to run on Python, but it makes a lot of sense for some of those silly sonar types of findings that you keep pointing out to your colleagues that they should be doing things differently to be able to run both on Java and on Python and on C Sharp and all of the languages that we've similarly met. Now, beyond core languages, there's also a lot of supporting technologies that we have had to support to be able to maybe upgrade your Maven dependencies, because those are mapped in XML, and we need to parse that and be able to manipulate that such that you can do the necessary changes there. Similarly, your properties files or your YAML files need to be parsed, or maybe you have some Terraform things defined in ACL. All of those we can parse with that on the left-hand side, and then move up the abstraction level slightly to support the libraries and frameworks that you might be using. Now we have a lot of support for Java libraries and frameworks, but we're also expanding this towards more .NET and JavaScript, TypeScript type of frameworks in the next quarter. So while we have a ton for Java folks right out of the box right now, if you don't use that yet, don't despair. The help is on the way. It just needs us. We need a bit of time to build up that same catalog for other languages still. And beyond that, if you use something common like GitHub Actions, CircleCI, Concourse, GitLab, or any of the deployment platforms that you see on the right, then we already have recipes to help you there as well. Because you might have a lot of copy and paste between your projects for any time that you want to deploy something to Kubernetes. And you might want to move away from outdated V1 beta types of API versions towards the newer ones. And we have the recipes to help you along. So that's somewhat types of technologies that we cover, but there is a lot more. Like I said, we have over 3,000 recipes, and this is just a sampling of some logos that we pulled onto a slide. Now, beyond that, there's also different types of use cases that we can cover. So I won't go into each of these in depth, but like I said before, there's migrations going from one version to another, but there's also migrations going from one vendor to another. So if you are using Hamcrest or JUnit 3 and or TestNG and you want to move to AssertJ for your assertions, then we have recipes to help you there. Similarly, swapping out even a customers of ours, swapping out Oracle database for Postgres is something that we helped them automate. And it's not something that is available out of the box, unfortunately, through OpenRewrite just right now. But it is something that's possible when you have this types of use case. And there's similar types of migrations that we support, which go beyond just version upgrades to really making code changes to adapt to a different API. Now, there's also a lot of recipes that we have with an eye towards security, where you'll probably recall something like Snake YAML, where there was not so much the version of Snake YAML that you're using, but it's whether you're using one constructor or the other. And we have recipes to move you between those two. Then there's also a lot of recipes where we're able to look at your dependencies and also transitive dependencies, and then upgrade those versions to move you away from vulnerabilities. There's a lot of tools in this space don't really look towards transitive dependencies much because they don't have the smarts to do much about it. Whereas we're able to introduce new code blocks, as I showed you previously. And that allows you to then also upgrade those transitive dependencies by introducing a dependency management block, Maven, or introducing version constraints in Gradle, saying that you want to use at least this version going forward to be safe from any vulnerabilities in the outdated version you were using. Now, like I said, beyond that, there's a lot more types of use cases that we have. One that I very much like is the automating away feature flags that have been enabled for a year or two, which is something that you just never quite get to, but you're going to scroll past a lot over the years where you find that this feature flag has been enabled for quite a while, and then you have the associated conditionals, and you want to move just fully enable or fully disable that one. And when I had a long flight delay, I wrote the recipes to do that type of migration, which is a lot of fun. So know that such use cases are possible as well. And if you have any more, throw them in the chat. I'd love to share what we have or what we think could be useful stuff. And the next slide I have here is my Slido slide, which for some reason isn't shown as I'd hoped. I think we're going to do the questions just via chat, because this should have popped up a Slido link. I'm not logged in. I was logged in just 10 minutes ago. Yeah. So we're just going to do the questions in the chat then, I think, which is a bit annoying because then you can't upload new questions. But I don't feel like debugging this right now. Or I can create a new slide right now. Yeah. Where did it go? Audience Q&A. Yeah. Okay, sure. Copy joining link. I'll throw a link in the chat. This should work. So if you have any questions, just pop in there, and then we'll take it from there. So I've talked long enough, I think, on slides. So let's actually start to show you things. And for the first thing I want to show you is the integration that we have with IntelliJ. Because the really neat thing here is that OpenRewrite is likely already installed on your machine. And for that, I'm going to switch to my browser tab, and I want to show you exactly this one, or IDE tab, where you can see that I have a silly example project. It doesn't really matter much what's in it. It's just there's a README here, which I can show you a bit. It is a project which is heavily outdated. It is using old versions of Java, old versions of testing libraries, old versions of Spring, and we want to upgrade it to the latest versions. So what I've done here is I've written a recipe that we have right here that allows you to do something about this. So what I'm not going to do is I'm not going to show you ahead of time just all of the things that are in here. I'm just going to run some recipes and see the types of changes that we would suggest if we were to run this migration. So the thing to note here is that I have a YAML file, and I've added this to my project. You can also add it to your scratches in your IntelliJ. And if you are using IntelliJ Ultimate 2024.1 or newer, then you have support for OpenRewrite. And you'll see that by our logo popping up on the left-hand side here. And you'll see that by this play icon that appears on the left here. And if I press this one, it will, in the background, execute our Maven or Gradle plugin to upgrade this application, in this case, to use AssertJ and use a JUnit 5. And it takes a bit of time to run. It takes about as long as it would take to compile your project, because we need to compile your project to build up the model of your code, enrich that with the type information that we need. And then once we have a model of your code in memory, we need to manipulate that model and write it back out again. And this typically it's proportional to the size of your project. So if you have a project that takes you 5 minutes to compile, it'll take you 5 or so minutes to run an OpenRewrite recipe. And then the changes you end up with is all of this. So let me try to show you this in a decent view. Here you can see that we had usage of Hamcrest. It was using Hamcrest assert that, which is very similar to AssertJ, but it is quite dated because Hamcrest has had, I think, one release in the past 3 or so years, where AssertJ has continuous releases about every month or so. And the API is very similar. Assert that money is not null value, but it's all using individual static imports. Whereas with AssertJ, you use one static import, and then you have a fluent API that allows you to discover the next method to call. So it's very similar. but it's just a bit easier to read. It's very much easier to write. And you also get the benefit of a library that's actually been maintained a lot. And this further, we do some changes to get you from JUnit 4 to JUnit 5, where we remove the public modifier where it's not necessary. We also remove this test prefix on the name of your methods, which was necessary in JUnit 3, which was replaced by JUnit 4 in 2006. So if you want to use move away from a pattern that is 19 years old by now, you can run an automated recipe to rename your methods here. It kind of sounds silly, but it does make your application feel like something that was recently maintained, as opposed to something that just gone through a number of upgrades. Now, next change that we can pull up here is say that you were on JUnit 4 already, but you were using some of the timeout attributes to the test annotation. Then you'll notice that we're introducing a new annotation with the same argument and then adding in the milliseconds here. Or you were using, what else do we have here? A test rule. This is then transferred into using the temp dir with a different type as well as all the necessary changes to, in this case, instead of using folder.new file, now use file.create temp file. All silly little things, but if you still have a project that is maybe not using JUnit 5 to the very best of your abilities, or you're not using assert J and you want to, then we can apply this recipe to do the necessary changes. And there's also some subtleties here where if you were going from JUnit 4 to 5 without swapping the argument order here, then you would start to do assertions on the message rather than the type of that you want to do assertions on. So this is something, like I said before, where your compiler won't help you, but we have the recipes to do that change for you. So we can detect those issues and then move you over. Beyond that, there's some more. Like I said, we're also going to update your dependencies. So in this case, moving you from JUnit to use the last remaining bit of Hamcrest that you need. And then also upgrading for you to JUnit Jupyter here as well. So that's a type of changes that you could expect when you run OpenRewrite. But of course, this was just running 2 recipes. It gets a lot more fun when you run all of them at the same time. So I'll run these as well. I disable this one. And this will then do additional changes to upgrade you to Java 21 and to upgrade your application to Spring Boot 3.3 in this case. But we also have recipes for 3.4 as available as well. So this, again, takes 15 seconds or so on this project. And then we'll explore the changes one. So you see that beyond the tests that we already explored, there's now also changes being made to your controller. In this case, where you see that we are removing the auto-write annotation, which is no longer necessary on the single constructor that you might be using as of Spring Boot 2.0, but somehow is still in a lot of projects. It's one of those things that makes your application feel dated. Same with a path variable that uses an explicit argument, even though it's the exact same as the variable name. It's also no longer necessary to have those types of changes, and we have the recipes to clear those out. Here we have a change where if you just assign a variable just before you return it, you might as well return it immediately. It's a type of change that Sonar will give you a warning about and tell you to go back to your IDE and fix, whereas we give you this automated change already out of the box. And then beyond that, the dedicated annotations for get mapping. And then here is the one that I quite like, going to Java 21, where I don't know how many thousands of times you've written the get the element at index 0 on a list. And now you're able to call the method get first. Or the even worse, get for the list of size -1 at that index, or just call get last. And you'll notice that it's red, but that's because my IDE hasn't yet picked up on that we are now using Java 21. But trust me very much, this works, and it works in all the correct cases that it needs to. And the neat thing here is that my boss had completely missed that this was added to Java 21 until he was giving a demo and this change popped up in a demo. And then you thought, oh, I didn't know that. And that is exactly what we're after with these types of changes, where you don't have to go read some Java magazine and stay up to date on everything that was released just a couple of weeks ago, because you have enough things to stay on top of, but just see these changes pop up in your pull request. Because once they're here, it's also something that you'll very much copy and paste the next time that you want to do something, or that your AI assistant will pick up on because it's similar to what you're using elsewhere. So you just want to apply this once as a recipe, and then going forward, you'll have that change. Now, beyond that, there's like one more thing I wanted to show here in the service. We also have a change where we can say, well, this would look better as a text block, and then just make it a text block. That's the type of change that we think is very valuable. Or no need to add an explicit cast when you have instance of or newer Java versions. You can just define that variable right there and then. Or if you're still coming from something dated, Java 8 type of application, then there's no need to be explicit about your type anymore. You can use the diamond operator and do it that way. Again, all of these intended to make your application feel like you've been using Java 21 all the while, but we applied this in 15 seconds and we're never going back to using the old comments again. And then beyond that, of course, the regular changes you would expect on your dependencies, also updating your POM files to now use Java 21 when we compile your project, to upgrade your Spring Boot dependencies as necessary, even to upgrade Lombok, which needs to be on a newer version when you upgrade to Java 21. All the things that we've known and discovered that we can pull into this recipe is evaluated and applied, such as your application now uses Java 21 going forward. So that is out of the box recipes that we have, but there's more fun to be had if you look at custom recipes. So let me try to revert all of these changes very quickly. And then we're going to look at what I said, building block recipes, where you're able to define custom changes that you want to do on your own applications. Maybe you have an internal library or a starter that you share with colleagues, and you have that copied all over the place some couple dozen times, but it's using maybe a package that includes boot 2, where you would rather have that read boot 3, or you have a type that you think was misspelled and you want to change that. Then we have the option here to see that we have in this project a money maker class. It's right here, it's very silly, but we can rename it to money producer if we want to with a simple recipe. And then, like I said, if you have this in your scratches, then you're able to apply this to all your projects locally very quickly and easily to do this type of work. And of course, this is just one example of a change. But if we pull up the dialog, you'll find that it's replaced any place that it's actually being used. So that it's in tests, but also the definition itself is changed. All of it is now being named money producer instead. So that's a very quick and easy way to get started with custom recipe development. And the neat thing here is, I don't think it will show on my screen share, but there is support in IntelliJ with a pop-up of recipes that are available to you. So if you want to do something like you need change method name, then this will also be possible. And there's a lot more things to be done. But this is just one way to compose these recipes. So what I kind of want to switch to, and I'll close this screen, is a different way to compose those same recipes, because we want to make things easy for you. And for that, I'm going to share the Modern platform. Just a moment. There's some music starting somewhere. Apologies for that. I'm very much into home automation. So at the end of the day, some music starts playing. It's exactly 7, but it's not very handy when you're doing a live stream. So let's get back to the actual program. So what I wanted to show you is here that we have the recipe builder at app.modern.io. So if you want to compose recipes together in a nice and simple interface, then this is the place to go. So let me double check. Um, Here you can very quickly add new recipes. Maybe you want to change a package name, and that will then suggest you the recipes that we have available to rename your package. Yeah, that sounds about right. Then you can say, add me this recipe, and you can say from the software camera. I should brush up on my German. And then say, no, I want to instead use boot 3. And hey presto, we have a first custom recipe to do that type of work. And we can add additional recipes still. We can pull things in that are existing here already. But the really neat thing is when you start to combine this with the composite recipes that we also have. So there's a Spring Boot 3 best practices that we have. And if we add this one, then we go from a recipe list of 1 to a recipe list of, it takes a while to load, 5,592 individual steps that will be applied to your project. Now, there is some slight duplication in here, I know that, so I can remove this one safely, and I can remove this one safely. Yes. There's a slight delay because we're loading a lot of elements in this fancy browser here. But what you end up with is some 2,925 recipes that will, together with the one custom recipe that you've just defined, upgrade your application to Spring Boot. So if you are running this recipe and you're finding that you're not quite pleased with one of the recipes in here, maybe it's the formatted change that we do from on your Java 17 upgrade, then you can also find it here, remove it here, and then have a custom recipe that you can run on your own application. Because you can download this recipe and then be able to add it to a custom project that you have. So you can see here, there's one string.formatted recipe here highlighted. If you don't want to have that changed, then just simply remove it. And now you have a custom recipe that doesn't contain that exact one. This is also the place to go if you want to do that type of customization. And then the neat thing here is with this platform, we offer you a way to validate your recipes at a large scale. So what I can do here is I can press dry run, and this will run our bespoke recipe on some 200 Netflix and Spring repositories. All these Spring guides are in here, all these Spring starters are in here. A lot of projects from Netflix are in here. And this will run that recipe and show you the results that we would be seeing if we were to run this on those projects. Typically, it takes about like 10, 15 seconds before the first results show up. So that is a lot quicker than what you would see on a local machine. But this then also allows you to verify that these recipes work against open source software. Because we have this app.modern.io instance to showcase what our 2041 recipes can do against some 32,000 open source projects, just as a way of showing you the types of changes you could expect here. So let's see what the first one does. So in this case, we would be removing that last message ID because it's exactly the same as the last message ID variable here. And the neat thing here to note is also that this is a Kotlin class. So while we are running recipes that were designed to run on Java, they similarly apply to Kotlin as well. Finding out that there's absolutely no need to repeat yourself here because we can do so and pick this up from the compiler. We're also going to upgrade your Gradle wrapper and the Gradle wrapper script. I'll scroll past that one. Just because to be on the latest Java versions, you have to be on the latest Gradle version as well. And then if you think this looks good, you can create a pull request and upgrade the Spring Guides tutorial for Spring Webflux Kotlin RSocket. But we're not going to do that on this call. But the neat thing is here, if you go back, then we have a way to do this type of work across all of these projects. If you want to do a commit across, in this case, 47 projects to upgrade all of them to the latest Spring Boot and Java 21 version, then the platform is a way to do that. I don't immediately suggest that you do this en masse on open source project. Typically, you want to get some involvement from the authors before. But I do use this platform from time to time when I contribute to Apache Maven, where I can similarly run recipes and do automations, create pull requests, and do that follow-up just by using the platform that we offer at Madrid and use it to target specific projects that we have here, for instance, Apache Maven, and do these types of improvements. It's I find a very neat way to iterate on the recipes that you want to develop, to using that builder, try them out on open source projects, and once you have that confidence, go to the download tab, download it, and run it on your own projects as well. Now, like I showed you before, we have support for a lot of different technologies. You can see those on the app.modern.io/marketplace. I'll share that link as well. And there you can see that we support Hibernate, we support Cucumber, we support some .NET recipes as well, and C#. All of these are able to help you modernize your application across these various technology stacks. And wrote in Jenkins in there. Just if you have some wondering what all is covered, then this is where we suggest you go first. Now, one neat thing that we can offer the open source community as well is this type of insight into showing exactly where projects stand in their large migrations that you're looking to do. So in this case, for Netflix and Spring, we can see that the majority of them are on the latest Spring Boot version. Some of them are a patch version behind. So they're not on 3.4.2, but are on 3.4.0, for instance. Quite a few of them are on 3.3, 3.2, 3.0 maybe, and still some are on 2.something. This is a type of insight again, and then we have the upgrade recipe to help you upgrade that. And this is just how you would use the platform if you have access to that. So that's what I wanted to show you for composing recipes through Beek Builder and the IntelliJ plugin. And then we have a few more demos that I could run you through. But perhaps it's also good to very briefly look at the Slido link that I shared before, where I can see that there is a couple of course questions, and I'll go through those just to see if it helps to guide the presentation. And I'll share a different tab. Yes, this one. Slide in. Not that one, that one. So first question, is there a minimum size where it makes sense to start using OpenRewrite? Yeah, can you be too small as an org? To answer that one, I don't think there's a minimum size. So like if you saw me run this very quickly on a very small project, but likely you'll have something of Java 21 on all the features before it that you haven't fully applied yet. Or you'll have some kind of framework or library that you're using that you're not using to the fullest extent. Where I think everyone could benefit from having that type of automation. Because even if you're fully caught up right now, probably in 3 months there'll be a new Java version again, and you have to do again evaluate where you stand and where you want to be, and if you fully adopted all the features that you want. So I think there's not a good reason to not use OpenRewrite. So then the next one is, in order to generate higher level docs, we're currently using regex. Would the OpenRewrite model be a good thing to query our code for in a reasonable way? Very interesting case. We've recently added some work to the modern side of the recipes that we maintain, where we have recipes that allow you to comprehend your code. So what we do is we found that not a lot of projects have a decent README. So what we did is we wrote some recipes which will analyze your code. It will then hand off to a model, AI model, give me a summary of what all is happening in this particular Git repository, and then add to the README that summary of what you have found that this project does. And that is what we currently use to update our README. So we found that that works quite well. It's also the type of change that we trust AI with. We're not going to make AI code changes for you, but we do trust it to update your README because that one is not compiled and it can't fail. But so if you have similarly a use case where you want to extract some elements from your project and use that to inform the documentation that you generate, then yes, very much that is something that you can use OpenRewrite for. And also, as of last week, we had some discussions with Oliver Drotman from the Spring Modulith project, and we're exploring a collaboration there as well on like what can we detect in your project, what can we suggest in terms of code changes to your project, maybe add some explicit configuration to say these are the modules that you have, and then in that way generate your documentation for you. So yes, it's very much something that we're similarly exploring at the same time. And if you have use cases like that, do chime into our public Slack channel and we can explore some collaborations there as well. So I'll mark that one as answered as well. The next one, is there some Git integration? Maybe we would want to go in small steps commit, and let's say I run for that commit to see if we were running into some regression. There is not currently a Git integration, but you can choose to run recipes iteratively. So if you want to go from, you're coming from something very old, it's an old Java version, old Spring version, anything, and you want to incrementally upgrade, then we can choose, or you can choose to run the migration steps in a pattern that we've documented as well, where you first upgrade from JUnit 4 to 5, then go to the latest 2.7 branch of Spring Boot. Then there's an intermediate Spring Security release that you can migrate to, the Spring Security 5.8. And all of those help clear out some of the changes that you likely need as you go to newer versions of Spring Boot. You can also pull forward your Java 17 migration and run that one separately. And each step and increment you can bring to production and see that it works well, and then adjust from there if you find that there's further changes that are necessary on your specific project. And that then helps close the gap when you come to that larger leap of going to 3.0, Jakarta, and all of those types of changes. So there's no explicit support to do that type of change because we run 3,000 recipes. We don't think there's a lot of value in running, creating 3,000 commits on your project every time that one of them runs and hands over. But we have documented the steps to do iterative work on modernizing your services. So I hope that answers your question. So next one, maintaining libs, where to best store recipes to support our users upgrade from 0.7 to 0.9 or something. So the best place to start there would be to go to the rewrite recipe starter sample project that we have, which is very much intended as a template that you can use to develop your own recipes and share them with the wider community. So if you are maintaining a library and you want to write some recipes for it, then you can fork this particular project, remove some of the example recipes that are already in here, and then from there, write your custom recipes as needed for your bespoke migration. We have a pattern where we suggest that you write recipes in such a way that if you have first a recipe to get to 0.7, then a separate one that goes to 0.8 and then chains in the one for 0.7. And again, a separate one to go to 0.9, such that your users at each step can choose to pick a particular version that they're targeting and run all the recipes chained below that version. So the suggestion there would be to go to that recipe starter and get started there. There is also and I'll share the links in the chat here as well. And I think that will gather up some links at the end too. But there's also the docs.modern.io user recipe authoring workshop, which I'll also share here, which takes you through the steps needed to learn how to develop these recipes, and then uses this module to be able to learn about the various types of recipes you could be developing and how to package that up and distribute it up to your user. So I hope that helps and gives you a starting point on how to do that type of work. Does it make sense to use OpenRewrite recipes like good practices in a build via the main plugin to enforce certain code styles, etc., like a linter? Good question. I would say yes if your project builds in a reasonable time frame. So like I said, if you have a project that compiles in just like a couple of minutes and you're running it in CI anyway, and you can in parallel choose to run recipes to do that type of work, I wouldn't necessarily do this if it takes you 20 minutes to run a recipe, because then your feedback cycle before you're able to maybe even check in your project or before you're able to verify that it works is going to be quite long. But what I can show you is we have documented the steps necessary to be able to tie OpenRewrite into your CI systems, where we have on all the OpenRewrite and all the modern repositories, we are now running a set of recipes, best practices that we have defined on if you write a recipe, you should do it in this way, and you should apply these recipes to it. And then we have automated that in a way that will post helpful code suggestions on your pull request. So here you can see that a GitHub Actions bot account has posted some suggestions on this PR from a valued member of our community who's done a lot of detailed work on Java migrations. She works at IBM. She's done a lot of the hard things well already, but some of the small trivial things, they were not up to the standards that we like to see on the project. So for instance, when it comes to our tests, we don't want it to be public because that invites maybe using things across classes. We'd rather have that visibility removed. And like I said before, JUnit 3 required that test prefix on your test methods, whereas we'd rather see it with that. So what we did is we wrote a bot that runs those recipes on every PR that comes in, and then posts these code suggestions as something that becomes a one-click apply on your PR. Now, I've already applied it here, so you don't see the button anymore. But this is the way that we think this type of feedback should be given. It should be given in a very non-intrusive way. It should be given exactly where it's applicable on your PR, and it should be given in a way that is most helpful. This would not be very helpful if it were to be a big red cross on your PR telling you to go back to your branch, check it back out again, and then have that delayed feedback and cycle of through the work. But it should just be something that you click a button. Yeah, I agree with this change. Apply, 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 and then you never see those issues anymore. And I can tell you, this really helped lighten my load as someone who reviews pretty much all the PRs that end up on the OpenRewrite project. We have some 50 plus repositories, and then there's the modern side as well, where anytime I now get a pull request, the bot has filtered out all these silly small things already, such that I can focus on the higher level feedback that I want to give. And this is just a lot easier. And I've had some discussions before with folks like, should it be a bot? Should it be your personal account? Well, if you make this your personal account, A, your notifications, they're going to blow up, and B, your colleagues will not invite you to the next drinks rounds at the office because you're going to be the annoying one to point things out. Whereas the bot, they're very much inclined to appease the bot just by clicking OK, fine, apply, apply. And the other thing is, once you have this automated on all your repositories, you can also start to gradually expand the rule set of things that you enforce. Like I said before, we have a number of recipes that we currently enforce. And then every time that we find out that we are pointing something out manually on various PRs, we think, well, it should be a recipe. And then we write the recipe and start to enforce it going forward. Clear things out with the platform that we have on Modern to really apply that once and create all those 50 pull requests. And then going forward, you'll never see that issue anymore. So that is very much how I would say you should run these recipes as something on every pull request to clear things out. So you could do it locally. You can still run those recipes through your IDE, but I think this is the most helpful way to give that type of feedback. So that is all the questions right now in Slido. Of course, if you have more, then feel free to join and we'll explore from there again. And then there's a couple more demos I can do. There's a couple more slides I can do. I just want to give folks maybe a slight breathing moment where they can decide like what do we want to see next. So feel free to chime into the chat, and otherwise I'll just happily continue as we go. There's no input, and I'm just going to continue with a small demo. So one thing that I haven't shown you yet is we haven't yet dove into that rewrite recipe starter project. that allows you to view the existing recipes that we have that are part of the workshop that you can run through. And I also haven't yet shown you the modern CLI that we have. So the modern CLI is very neat in that it allows you to do all the same things that you can see with the OpenRewrite Maven and Gradle plugins, but it also allows you to run on something that is not a Maven or Gradle project. Maybe it's something for .NET, JavaScript, TypeScript, Python, or it's something that is just a bunch of Terraform files that you use for your deployments, or some YAML that you want to manipulate in a way. So we have a modern CLI that allows you to do operations on all of these repositories in this way. And the neat thing is that this one is free to use up until the point where you want to run recipes. But you can already use it for a lot of smaller automations that you want to do not on a single project, but across projects. So the neat thing here is you can see that I have a couple of Apache Maven projects checked out here in this repository. And I have the modern CLI to do operations across all of them. And the first type of operation first is to say, well, just list me all the projects that I have in here. And it will ask me to scan a folder. And in this case, I'm going to say, just scan the current folder. And what you then get is that the modern CLI tells you exactly, well, you have a number of Apache Maven projects checked out. Most of them are on the master branch. The ones in blue, those have a lossless semantic tree serialized for that project, making it very quick to run recipes. And the ones in black with the no LST suffix, those do not currently have a serialized LST for very rapid recipe run. But then what you can now do is explore some of the commands that we have. So for these projects, I've already built lossless semantic trees and serialized those to disk to allow us to skip the waiting period that you typically see when running OpenRewrite recipes, such that we can now immediately jump to running OpenRewrite recipes. So what I can do here is say mod run recipe, and I'm going to tell it to run a common static analysis recipe that we have, which applies some 70 plus Sonar type of fixes. And I'm going to run it on all of these Apache Maven projects. So it again has detected that we have some 95 repositories in here. And if you want to contribute to Apache Maven, then this CLI will allow you to do that across all of these projects in this way. So this will then load the serialized LSTs that we have, and it will start to produce these diffs on the suggested changes for those projects. Now these will load in a different tab. Let me try to open this in, open it in the browser in IntelliJ. Does that work? No, not so far working. So I can very quickly show a different tab where you can see these are the types of changes it's suggesting on this particular project, where if a variable is not final, but we've determined that it could be, then we're going to make it final just so there's no ambiguity there. Or if you have an equals comparison, but your comparison on the left-hand side is not a constant, but the right-hand side is, then we're going to flip it around such that if for some reason the left-hand side were to be null, then you won't get a null pointer exception. You can see that here on artifact type. We don't quite know if the artifact type might be nullable, or we can definitely say that it is if you see this type of comparison. So we're going to flip it around and say, well, now you don't have to necessarily do the null check anymore. So this could then be further simplified to say, well, if we see this pattern, then we can remove the left-hand side because there's no need to do it in twice that comparison. Some further changes here to say, well, if you have parentheses, then there's no need for them here, then we just remove them. And all types of changes that maybe have been suggested over the years by a tool like Sonar, but you can now finally clear out by running a recipe in this way. And you can see that in just a couple minutes, we already have fixes out for all of these Apache Maven projects. Now, I've not yet shown you the steps on how to go from these diffs to how to apply them and how to then create pull requests, because that is usually suggested at the end of a recipe run. And in this case, it took us 2 minutes to apply fixes across 15 to 20 projects already. But I'm not going to wait another 4 minutes to do the remainder of these projects, even though I forgot that thing. I'm not running in parallel. I could be running this in parallel to make it a lot quicker. So that's also one of the benefits of Immediate CLI. I did notice that once in a while when I do this, my video screen sharing tends to lock up because all my threads on my PC are being used. So we'll see if I manage. If I drop off, I'll promise to be back very quickly. But here you can see that we're doing things even quicker. So before it took us a couple minutes to get up to that 2 or so minutes for 20 projects. And right now we've already done in 30 seconds, half of the projects instead of 30% that we saw before. So this is really starting to show what you could do if you have those serialized LSTs to be able to speed up this work. So this, to be fair, I have to say the serialization of LSTs is unique to Modern, but we do offer it for free for any open source project. So in this case, you're seeing me do this for Apache Maven. I could do that all the same if I were not working at Modern. And it's something that we find is just very valuable to give back to the wider community, to allow them to, in 1 minute, update some 61 repositories and clear out all their Sonar type findings. And then after running that recipe and giving you a preview of the changes, we will suggest the next steps. Maybe you want to create a new branch to across all of these projects to say, well, we're doing a refactoring and we're clearing out common static analysis issues. And then you want to apply the changes that were created in the last recipe run. And then from there, there'll be, after running those, there'll be a suggestion to do a commit, create a branch, push up that branch, maybe create a pull request. There is a lot of these types of automations you can do across, in this case, some 90 or so projects just by using the Madrid CL. And like I said, it's free to use on your own projects as well. The only exception is that mod rewrite. But you can also use the mod exec to execute arbitrary commands. So if there's something that you want to do, like a quick streaming editor replacement or a quick awk command, then this is something that you can use to do CLI. It will discover all the projects that you have, even nested in a folder, and be able to run commands very easily that way, and do that follow-up. So that we feel is very helpful. And I wish I had this back when I was still a consultant, doing this type of manual work and writing bash scripts to do this ugly little things that are just so much easier if you have the right tools to do so. So that is something on the CLI. And then I could still show you a bit is some of the recipes that we have and how to implement them if you were to use the starter project that we have. Maybe we're
Tim,
good to check, like,
Tim?
yeah.
There
Yep.
was a question about starting from scratch with a custom recipe using Maven or Gradle.
Mhm. So that is, so if you want to write a custom recipe and then still we would suggest to fork this rewrite recipe starter. Otherwise, there's also documentation pages that we have on how to set up your own project if you don't use our starter. But those are just slightly more complicated. There's things to get wrong. There's things that you want to get right. And we find that using our starter is the easiest way to do so. But otherwise, it is documented, and I'll help you find that if you want. And we also have a Slack that you can join if you have any kind of questions, and I'll gladly walk you through. All good?
Okay.
So then,
Uwe says thank you.
perfect. So I'll very briefly show you in this starter that we have those example recipes available. So we have one example here where we're going to swap out the string framework string utils class for the Apache Commons string utils class. And we're going to add that dependency if you are still on the string utils class. And then in the workshop, we have an exercise that will export this to rename one or two silly methods that are named differently in the string utils class as they for Spring as they are in the string utils class for Apache Commons. And this, like I said and showed you before, is just going to be a declarative recipe that you can run and test run in your IDE just using the play button. But we also have ways to allow you to write or refaster style recipes, where you had that before and after template annotation. And you can find silly patterns like this one. If a Boolean expression is evaluates to true, then return true or false as a ternary expression. Doesn't make a lot of sense when you can just return the Boolean condition itself. Similarly, if you have the inverse, where it's if this then false, otherwise true, that we can just return the same Boolean expression, but then negate it. And this is all you need to write that recipe. And similarly, we have an exercise where you can copy this approach of having a class with two annotated methods, but use it to do checks to see if a string is empty or not. And we have some tests associated with this as well, because every time that we write a recipe, we also write tests to go along with. So right now, if I run this recipe, it will completely fail because nothing has been implemented yet. But it does give you an indication of that we expected this recipe to make a change, but it made no change at all. Because what we have with our testing framework is just a way to say, well, given a Java class as input, when running this particular recipe, I want you to run it and then assert that the replacements actually look like this. And this is how we write all of our recipes. It's also how we typically start with the recipes that we write, because we want to be sure that whenever you're doing replacements, that you're going to end up with exactly what you were expecting. We definitely don't want you to wait 5 or 10 minutes before OpenRewrite has run on your project to give you feedback on if it's actually doing the thing you're looking for. Whereas having a test framework that allows you to do these quick assertions really helps speed up that process. And then there's some further changes here that we're expecting as well. Cleanups where we can say, well, if we're doing this, then we should also replace it just with the field that is empty. A lot of cases here as examples of what you could be using refaster for to do replacement. And then the workshop will walk you through exactly how to do that. So then moving on from there, if you want to, if you find that you can't do what you want with refaster or those declarative style recipes, then you typically arrive at this imperative style recipe. So here you have a recipe. This one is written in Java, but we are also expanding this to allow you to write recipes in C# for C#, in Python for Python, in Kotlin and Groovy for Kotlin or Groovy, or even targeting Java again, to allow you to do this type of work. And then we have a couple of utilities here that I've called out with comments to show you exactly what we're doing and why. But what I always like is that we first look at the test to see what are we even starting to do here. Well, this recipe is intended to do replacements on the usage of Guava lists.newArrayList, which before Java 8 was a convenient way to create a new array list without having to be explicit on the type that you needed for your list. It would just pick this up from the generics. Whereas previously you would have to be explicit here, but starting with Java 8, that's no longer necessary. And this then starts to feel very silly to still have Guava as a dependency in your class just to create a new array list. Similarly, there were some variants here. There, if you have an existing array list that goes in there, then you also want to do a replacement there. Or if you had a array list with a specific capacity, now you just have an array list with that same argument in here. So again, types of like replacements that you want to be doing. And then there's some edge cases where I have additional tests to show you exactly why we have certain elements in the recipe that we've implemented. So with that kind of clear, like what the recipe is after, let's look at how we have implemented that in this particular recipe. So the basic structure is always that you extend our recipe class. There is also a scanning recipe class. It's a different type of recipe where if you want to do two passes. First one over all the projects, and then a second one on the classes that you want to be modifying. But in general, you can start with extending a recipe, and then you'll gradually learn when to use the scanning recipe. Then the most important method that you want to override is the get visitor method. The other ones, they're boilerplate just to give something of a name in the when you run a recipe to see what has actually changed and show things directly in our docs. But you'll want to override the get visitor. And then within that, there is some optimization immediately that you're going to see where we have some preconditions. Preconditions are a way to allow you to speed up your recipe run by very quickly rejecting certain compilation units that are just not interesting to you. If a given class or source file that you're evaluating doesn't use Guava at all, there is no sense in running this particular recipe there. It'll just take time to evaluate all the classes in there, all the methods in there, and all of that. So you want to reject those. And for that, we have a quick index defined upfront that allows these preconditions to quickly run and reject, and then only continue with evaluating and modifying your project when these are actually matched. So in this case, we're saying, I want you to be using one of these Guava new array list methods as defined here as a method matcher, where you can say, well, given this type and this method called on that type, then I want to apply changes to this particular source. And what you then go to is you want to, within your visitor, you want to override one or more visit methods. So one common one is the visit method invocation, which will visit any method invocation, not just the new array list from Java, but any visit method invocation will be invoked here and given the argument of and a bit of context that we need at times to be able to do more advanced things. And then from there, you'll want to again match, am I actually looking at that new array list that I was interested in? Is it the new array list without any arguments? Is it the one which has an interval as an argument, or the one with a capacity as an argument? And if we find that we match one of those, then we jump to the next step of removing an import. We're going to be explicit about the imports that we remove. Sometimes there might be missing type information, meaning that we can't fully determine if we can remove an import. But this will remove the import if it is found in your class. And maybe here indicates that if this is not the only usage of Guava, we're not yet going to remove your import. Similarly, we're going to do a replacement. We're going to add a call to new array list. So we want to add that import explicitly as well. And then we're going to use a utility that we have within recipe development called the Java template. And this one is defined a bit further up, but we apply that Java template as a convenient way to build up a new lossless semantic tree element, like an ASC element, saying that we now want to invoke the new array list constructor and give it these arguments. And I wanted you to insert it in the place where previously we had that original method. So that then calls out to this Java template, which is a small bit of boilerplate to say that you want to have this snippet of code compiled in just enough context to be able to create that LST element. You want to, for that bit of context, have the array list as an import available. And then you want to get back that exact element where you're inserting. Now we have the other variants as well, where any collection might be added into the as a first argument, which you can optionally match, or any integer might be added in as well. So these become the parameters that you can define when we apply this template. So we had that apply method here, and then this one takes from the original methods the arguments on the original method, the first argument, and then applies them to the template that we create to create the LST element, and then we return that element directly. So you'll find that there's a couple of directive returns here, and there is also one call to super.visit method invocation. Now this one is quite important, and I'll show you in a bit when we come to running the test. First, I'll show you that these tests should all run and be green already. And then we're going to break it ever so slightly by, instead of calling out to super.visit method invocation, we're just going to return the original method itself. We not matched any of the methods that we're interested in. So we're not going to call out to super.visit method invocation. And this can at times be a deliberate choice not to do so, but that might also mean that you start to miss cases. Because when it comes to the visitor panel, you are fully in control of the traversal of the lossless semantic tree. So if I were to run these tests now, you'll find that one of these has started to fail, which is the test helpfully named show need for supervision identification. You need to do something here. And here you will find that we have a test class. It has a field that has a method invocation, and that itself has an argument, which is the type of method invocation that we're interested in. But since we did not call super.visit method invocation on the collections unmodifiable list, we did not visit the arguments to that original method invocation. So we never saw in our visitor this list.new arrays. So this is why you want to be very deliberate about typically always calling that super.visit method invocation, such that even if you're not matching a method that you're interested in, you're still going to call out to the super implementation to visit any of the arguments that might be on there, any of the annotations that might be on there, anything that might be in the body of the method definition that you might be visiting. All types of things that you could potentially mess up when you start to write your own recipe. But if you know the visitor pattern and you know that this is something to look out for, you typically spot that quite rapidly, and then continue on, add the super visited method identification, and be done. Now, one thing I skipped over previously is that we also have an additional utility where we allow you to visualize the elements that are available in the lossless semantic tree. So I've here overwritten the visit compilation unit that there's no direct need for me to override this one particularly here. But I did want to show you the elements that are in this lossless semantic tree. And for that, I call the tree visiting printer to print the tree of the complete compilation unit. So just the Java source file that you have and all the elements that we have found within it. And then we print it out, and then we call super.visit compilation unit, because if we didn't, we would never see any of the elements further down. And this then shows you exactly for that case that we skipped over previously, all the elements that we have found in the compilation unit. So that starts with the various imports that we have of the com.google comment collect, and all the ways that those are structured into identifiers and field accesses, and to until finally you get at the input, and the class declaration, which itself then has a identifier, itself the name, and the block of elements within that class declaration. And this is where you start to see that we have a comments unmodifiable list, which itself has some arguments within it, and that then contains the lists.new arrays that we're actually after. So that tree visiting printer is very helpful if you're just learning the structure of all that is into makes up your LST, to be able to know what's around here. If you set a breakpoint, you're able to call out, do that printer, find out what's around me, what do you want to modify, what do you want to maybe replace or pull out and return as a larger migration, structural migration, and then be able to do that type of work very easily. And of course, the testing framework that we have really helps to be able to set breakpoints here as well. So that is some of how you would approach recipe development. And then there's more use cases here that I don't think we're going to cover, because I've already been talking for close to 2 hours, and I think folks are up for a bit of a break. But know that there is more examples here. If you want to do more advanced things, like I said, do a scanning pass across all sources first and build up a bit of knowledge before you start to make changes. Or maybe you want to do a data table export, where you want to extract some elements from your code and create a data table that will become a file in your target folder or your build folder, where you can use the information that you've gathered to make maybe generate your documentation in the same way. So there is a lot more that you can learn here. But the best way, I think, to continue your learning on this topic is to look at some of the resources that we have available on our YouTube channel. If you go to this link, and I'll share it, and I'll briefly share my screen as well, then you will find that we have a lot of videos that go into specific elements of writing recipes. So if you want to know more about the IDE plugin that we have, then there's some things that go into there, or how to write plugins or use the OpenRewrite plugin for IntelliJ, or like I said, how to upgrade your project to Java 21. All of these topics are covered in individual videos that you can watch, typically a couple minutes, to allow you to learn exactly how to do those elements. And then I have those linked as well throughout the workshop and the documentation. So the workshop at Modern, that will heavily link out to the OpenRewrite docs. Those docs will also contain links to YouTube, again, with the videos every time that you need it to learn about this particular part of recipe development, but all in such a way that we hope to make it very easy for you to do the custom use cases that you're after. Because we hope to grow our community of recipe authors in this way, such that more and more use cases can be covered out of the box already. So with that, I think we're kind of getting near. I'll show some final slides, and then we can open up to a further discussion. So I showed you a bit of the Modern platform. That one is really aimed at allowing you to collaborate on recipe runs and do those at scale. So you already showed, I showed you the dashboard that we have, where you can see where you stand in your migration, and have an upgrade button to pull you towards the latest version of Java, Spring, or whatever framework you're after. We also then allow you to do the follow-up, create those pull requests, and send a single link out to your colleagues, where you get 50 pull requests that you can in bulk review, in bulk approve, and in bulk merge. That's something that we do every day, our customers as well. But we find that is very helpful to have. And then this pattern I also showed you already, where you can automate these integrations and run them on your pull requests, such that it becomes that one-click apply to move away from those outdated patterns that you want to move away. And then this slide is probably the best one to show you the differences between what you can do and achieve with OpenRewrite and what you can do with Modern. So on the left-hand side, you can see that there is various solutions built on top of OpenRewrite. So of course, there's our own Maven and Gradle plugins that allow you to run these recipes. But there's also the integration into IntelliJ from JetBrains, where they just use OpenRewrite invoking plugins that we provide to run the recipes there. Similarly, there's integrations into Microsoft Visual Studio Code through the Spring Tools suite project, where our friends at Broadcom are developing recipes. And then there's solutions like Amazon Q and Broadcom Application Advisor, all of which leveraging OpenRewrite. But the thing that sets Modern apart is that we're able to take that slow step of building up a model of your code, which again is takes about as long as it takes to compile your project, which can be like 20 minutes, 30 minutes on a larger project, or a couple hours if you have a large monolithic application. And we're then able to serialize that model to disk. So where you saw me run recipes on some 90 Apache Maven projects and it completed in a minute, if you were to use OpenRewrite, you would still be parsing the first project before you're already done with the last one. And that, of course, is going to be a very different experience if you're doing your day-to-day work, if you're able to have a feedback cycle of half a minute versus a couple of days if you have a couple hundred projects that you need to upgrade, and all of them take 15 minutes or so to build and run a recipe, and then find out that you need additional recipes that you still need to develop locally, and then tie those in and do that iterative process. Really, what we think you want to have is that serialization to speed things up. Then you also get the IDE plugin to make things even easier there. If you want to learn more, then there's a ton of resources. There's the docs that we have at OpenRewrite. There's the Modern website and the platform where you can run these recipes. And there is just if you want to help out, there's the github.com/OpenRewrite. We have I think some 30 to 50 recipe models that you could contribute back to. If there's something that is of interest to you or you find a small issue, definitely chime in and we will figure out the next steps on how to get that yeah, moving for you. And then, like I said, there's the YouTube channel where we have a lot more resources where you can learn more about doing anything related to OpenRewrite and Modern and to the custom recipe development that you're after. So that's pretty much my slides. So thanks all for sticking around for this long. Let me quickly glance. I don't think there's new questions coming in, but of course there's always free room to chime into the chat or ask anything there. But know that it's very much my passion project. You can reach me at all hours, and I'll yeah help you along as best I can. And then yeah, hope to be in touch with yeah whatever you folks are looking for in this type of migration work.
Thank you so much.
Yeah,
Yeah.
thanks.
This was wow. Like
It's
1.5 hours whirlwind through OpenRewrite. Yeah, I
and
learned a lot, and I first of all there's something in IntelliJ that helps me writing this. I didn't know it.
mhm.
I
No, no,
always yeah
that's yeah, very much.
yeah
We were surprised to see that, and of course happy to make it even easier for folks to yeah to run this already. And then yeah, on top of that, we have our own tools to speed things up and do this type of work at scale. But it's I don't know, it's great to see how much easier the setup has become whenever I give a workshop, where folks are surprised to learn that it's already on their laptop. It's
yes.
just great for me.
Okay, so yeah, there's still room for questions. Maybe first thing I do is I stop the recording. I don't know whether we
Yep.
can upload
That
so much, but yeah. So if you want
okay.
to ask more, then it's not on the recording anymore. Uh, so maybe feel free to put on your camera and ask away.